Good day, class. We are in for physics again. This is Mr. Adewale, your teacher. So today we'll be considering a very vital topic in physics, dimensional analysis. And I know it's quite interesting. You are going to enjoy it. Just pay attention as we consider it together. Dimension analysis. Can we go into it? Dimensional analysis of quantities. Dimensional analysis is a systematic approach. I call it a systematic approach of analyzing quantities in terms of mass, length, and time. When you do with dimensional analysis of quantities, the three parameters that are involved are mass, and it's represented by capital M, length, capital L, and time, capital T. So those are the three parameters we work with when we consider dimensional analysis of quantities. Please settle that in your mind. Mass, length, and time are the three parameters we engage when we work on dimensional analysis of quantities. So we're going to attempt some of them now, as you will see. The first one now, question now. Supply the dimension dimension analysis of, so we start with the first one now. So we're going to start with velocity. Let's start with velocity. We say velocity. Velocity is displacement per unit time. Displacement over time. Now, displacement is distance in a specific direction. So displacement is a distance, is a form of distance. So we are talking of length. So distance from any direction speaks of length. So that is length over time, that's t. So velocity will be L, bring it in indices, t now. When you division will turn to minus, raised to power minus 1. Under indices, division turns to minus. This is t raised to power minus 1. That's t. So it becomes t raised to power minus 1. T raised to power minus 1. So that's the dimension analysis of velocity. I hope that is clear. Then the second one, let's consider speed. Using speed. Speed is distance over time. So that will still be length, that's distance is length over time, and invariably that will also be LT raised to power minus 1. LT raised to power minus 1. The third one that we are considering together is that acceleration. I hope you are following. Acceleration. What is acceleration? Acceleration is the rate of change of velocity with time taken. It's a time rate of change of velocity. Time rate of change of velocity. That's acceleration. So that is velocity per unit time. Per time taken. That's acceleration. You should know that. And we have gotten velocity. Velocity is what? The dimensional analysis of velocity is what? LT raised to power minus 1. Divided by time is t. By indices, this will be LT raised to power minus 1. This is my 1 again. As it comes up, becomes minus 1 again. T becomes this raised to power 1. Division comes to minus as it comes up. That will be LT raised to power minus 2. I hope that is clear. How did you get this minus 1? T is same thing as t raised to power 1. So but division sign under indices. Note that in indices we have a raised to power x divided by a raised to power y. It becomes a raised to power x minus y. These indices, you should note this. So the same principle applies here. Division, this raised to power 1, it comes up like this. Thank you. So the next one, we want to check. Let's check for we're going to check for force now. force. First, let's do this side. What is force? Force is mass. Force is mass times acceleration. That's mass multiplied by acceleration. Acceleration. And that is what's mass. That's m times a. And mass. Then we have gotten dimensionality of acceleration the other time. That's lt raised to power minus 2. So that will be mlt raised to power minus 2. That's the dimensionality of force. That's the one for force. The fifth one, moment. Let's consider moments. Moment. What is moment? Now, for you to be able to get the dimensionality of a quantity, you must be able to define that quantity. Moment is force times perpendicular distance. Force multiplied by perpendicular distance. The fifth one, moment. Moment is force multiplied by perpendicular distance. That's the formula for moment. So, and we have gotten our force. So force, you can say simply say force times distance. Whether perpendicular or not is still talking of distance. That's L, length. So force, as you have gotten, is mlt raised to power minus 2. Remember, we have gotten that force is mass times acceleration. Acceleration is lt raised to power minus 2. So mass times acceleration, that's force. Then times distance. Distance is length, L. So that will be m. This L raised to power 1 already. So times will becomes plus indices. This raised to power 1 becomes plus 1. T raised to power minus 2. And so our answer is ml2 t raised to power minus 2. This is the dimensional analysis for moments. Please check it. I hope it's clear to you. Now the next one. Can we do the same thing? Dimensional analysis. Let's do it for work. Work. What is work? The sixth one, work. 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 Work is force times distance. Work done is also force times distance. Work done is force multiplied by distance. Force times distance. So, what is force? We have gotten force to be mlt raised to power minus 2. Distance is also L. That will be ml 1 plus 1 t raised to power minus 2. ml2 t raised to power minus 2. This is work. This is also where we see, we check it, moment and work. They have the same dimensional analysis. You should note that you could have a question like, which of these have the same dimensional analysis? Moment and work. Speed and velocity. We have done that. Speed and velocity. They have the same dimensional analysis. Moment and work, they have the same thing too. So you should note that. Let's do the next one. Next one, power. 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 What is power? Power is what? The time rate at which. What is power? Power is the time rate of doing work. Is work done per unit time. Work done. Power is work done per unit time over time taken. So work done. Work is what? Is what we have gotten ml raised to power 2 t raised to power minus. Time is t. That will be ml2 t raised to power minus 2. This is 1 now, and it comes up, that's minus 1. ml2 t raised to power minus 3. This is the dimensional analysis of power. Power. So the next one now, we're going to find for pressure. Let's do it now. Consider pressure. Pressure. What is pressure? Pressure is what? Force per unit area. Force per unit and force over area. That's pressure. So, what is force? We have gotten force the other time. Force is mass times acceleration, and that's mass. Acceleration is lt raised to power minus 2. Now, divided by area is length times breadth. Length. Breadth also is also a form of length. That's length. So, and that's mlt raised to power minus 2. 2 divided by L2. That will be M L, this is L1 divided, that will be minus 2, 0 raised to power minus 2. M I hope that is clear to you. So we have done 8. We have got the dimensional analysis for 8 quantities now. So I'm going to give you just 3 or 4 for you to practice with, and then I will appreciate that you drop your answer at the comment section. And please do not hesitate to give whatever comment or observation you have as touching this video. We are in to see that you do well and excel. God bless you. So the exercise will be given now. This is exercise. Give the dimensional analysis of the following quantities. Provide dimensional analysis of the following quantities: impulse, density, momentum, Young modulus, stress, strain, kinetic energy. So do well to do this, attempt this, and let us have your answer in the comment section. Again, your observations are very crucial. Whatever you feel can improve and help this video, or whatever topic you feel must be considered or taken, do well to put them at the comment section. We will surely appreciate them. God bless you. Thank you.